Okay, we're checking the quiz preview for Trig Quiz 4 now. Find the exact value of the cosecant of theta if the sine of theta is negative 18/19 and you're in quadrant 4. That's my 4th hour for you. All right, thank you. So all I did was do the reciprocal because cosecant's the reciprocal of the sine. Number 2, simplify this. You better know what sine squared plus cosine squared equals. So this is 1 over the tangent squared, and then you would simplify that to the secant squared theta. Oh, I don't know why I wrote secant squared. My brain was somewhere else for a moment. I literally was thinking about something completely different. I should just record that over again. What is the reciprocal of the tangent squared? I mean, you could prove this by doing, this is sine squared theta over cosine squared theta, tangent is, and then multiply by the reciprocal, and you can prove that that's equal to cotangent squared. Now, I would actually I would even be fine with you going from here to there for this particular one. Okay. All right, number 3, 1 over the secant plus sine squared over cosine times the cosine. Well, I'm going to change 1 over the secant to what? Secant is 1 over the cosine. 1 over the secant is the cosine. Okay, so that's cosine theta. Plus, I'm going to leave that one alone because it's in sine squared and cosines. Sines and cosines. And now having a multiplication of the cosine at the end, you still are distributing. So if I multiplied, I would get cosine squared theta plus cosine times that. The cosines would cancel out, and you'd have sine squared. And then cosine squared plus sine squared is 1. Okay. Number 4. Verify. You only can work one side. I'm sorry how this is typed. It's very strange. I'm thinking I'm going to do the left side. Okay, so I'm going to trade 1 minus the sine squared for a cosine squared theta. And I've got tangent squared theta plus 1. This is secant squared. Tangent squared theta plus 1. You cannot change the right side. So if you write secant squared equals secant squared, you will have half your points off. Okay, you have to change the left side. So since the secant squared is equal to tangent squared plus 1, you replace secant squared with tangent squared plus 1 so that you have never touched the right side. Only one side can be worked. And that would be the end of that identity. 5, the first number 5, I noticed there were 2 of them. I'm going to rewrite everything in sines and cosines. Secant is 1 over the cosine theta over sine theta times cotangent is cosine theta over sine theta all over cosecant 1 over the sine. Next, I'm going to think about the fact that if I take a fraction and I divide it by something, I have to multiply by its reciprocal. The something I have to do the reciprocal of is the sine of theta, which would be 1 over sine theta. On the second fraction, I have cosine theta, sine theta. I'm going to change the division to multiply by the reciprocal of 1 over the sine, which would be sine theta over 1. Okay, now I'm going to do some cross-canceling. Sine cancels out with sine, 1 of the cosines with the cosine. I am actually replacing all of these with 1s. And I have a bunch of 1s on top. 1 times 1 times 1 times 1. We got 1 over. In the bottom, what's left is 1 times 1 times 1, sine theta. And now I say, well, I know 1 over the sine is the cosecant of theta. So I have proven the identity. All steps must be present. Okay? Hopefully you had it at least started if you didn't quite finish or know what to do. Number 5, the second number 5. The second hand of a clock is 2.8 centimeters long. Now, we have a clock in the room. If you want to look at it, the second hand's the red one that's spinning around. Where's that second hand coming from? Well, it's a little bit longer than that on our clock, but it's actually going... Now, if you're going to say the second hand of the clock is 2.8, how far does the tip of the second hand travel in 30 seconds? So it would go to there, right? That would be 30 seconds. So now it'd be pointing down there. How much is that? In radians? Pi. It's 180 degrees, which is pi radians. All right, so we've got theta. It says how far does the tip travel? That means we're finding an arc length because it's a curve. So S equals R theta is the formula. We've got theta is pi. And we've got, what's the 2.8? It is the radius of the circle. Okay, so we've got S is equal to 2.8 centimeters times pi. So if you want to write it in terms of pi, it would be 2.8 pi centimeters. Oops, I don't know what happened to my centimeter word or abbreviation. Came out goofy looking. So it's 2.8 pi centimeters. If you did it in decimal form, that would be 8 or 8.8 centimeters. Yes. Nope. No, it does. Nope. It's very much like this, where I'll take it either way. I'm going to have both answers down. So I would go to, well, I had said that we should go within the problems, definitely to at least the hundredths place, but most of them I've rounded to the 10th. At least on this, I have done most everything to the 10th. I say never go to the whole number. At least give a 10th place. I'm not going to get real nitpicky about it. Okay? But if you rounded it to a whole number and you wrote 3 pi, I'm going to mark that wrong. Yes. Okay. All right, find the angular velocity associated with 10 RPMs. 10 RPMs means 10 revolutions a minute. You need to get rid of revolutions. That is not an angular velocity. Angular velocity is radians over time. Okay, so I need to convert it to radians. So how many radians in one revolution? There are 2 pi radians in one revolution. So you cancel out the revolutions, and 10 times 2 pi would be 20 pi, and then you have radians per minute. And now that's an angular velocity. Okay, number 7. Find V, the linear velocity if R is 14 inches and the point rotates at 55 RPMs. First step. I'm not going to write all that as I did on the last one. If I have to change 55 RPMs into an angular velocity, which would be multiplying it by 2 pi. And then I would have 110 pi radians per minute. Okay, you understand all I did was what I did on the last problem? Do you want me to show it? Okay. Multiply your RPMs by 2 pi, then label it radians per minute. Okay, that's omega. It says to find the linear velocity, you have a radius of 14. Linear velocity is r times omega. So our linear velocity for this question would be 14 inches times 110 pi radians a minute. The radians get dropped when you are writing your answer. 14 times 110. I have written it in terms of pi and in decimal form. In terms of pi, it'd be 1540 pi inches a minute. Okay, or if you did it in decimal, that's 4,838.1 inches a minute. You have to have the label. You will have a point off if you don't. If the label is wrong, it's half off. It's bad, yeah. Labels are critical. That is inches a minute. Where does the rad go? Well, the point is that it has to be in radians. You never actually have to write radians on something. If you're talking about an angle and you say theta is 2, that means 2 radians. Okay. If it says degrees, then you do have to convert it. 8. Find the linear velocity of a point on a gear rotating 400 degrees per second. It's 400 degrees per second. Okay, so we've got to convert degrees to radians. So first thing we're going to do is get theta. So we multiply by pi over 180. Okay, let's see. That's going to be 20 pi over 9. Okay, and then we need to convert that into an angular velocity. It says 400 degrees per second, so that's 20 pi over 9 radians per second. Okay, that is an omega. Okay, it says find the linear velocity. The formula is V equals R times omega, so just multiply this by 12, sorry. 12 inches times 20 pi ninths rate, and then it'll be in seconds per second, inches per second. If you calculate this, I'll write it in terms of pi, and I'll write it in terms of, no, I actually didn't do terms of pi in this one. I don't know why. Say you did. I'll show both ways. Divide by 3. That'd be 80 pi over 3. And it would be in inches per second. And decimal form, it's 83.8. This pen is stuck a second here. Inches a second. Okay. All right, next page, number 9. Easy problems here, I hope. Find the length of each arc. S equals R theta is the formula, where theta must be in radians. Pi over 2 is radians, so S is equal to 16 yards times pi over 2 radians. Type 16 times pi over 2, or just write 8 pi yards. If you did that in decimal form, it is 25.1 yards. Number 10, it's not in degrees. You can convert it, or you could look it up on your unit circle since you get to use your green sheet. That would be 2 pi over 3. 2 pi over 3 is radians. You multiply that by 13 centimeters, and that will give you S. So you can either write 26 pi over 3 centimeters, and in terms of a decimal, it would be 27.2 centimeters. Any questions so far? You can't reduce that because there's no common factor between 26 and 3. Okay. Find the area of each sector. Area of the sector is 1/2 R squared theta. We plug in R and theta. This area is going to be 1/2 of 8 squared times 5 pi over 6. In terms of pi, the answer would be, oh, I didn't do that one. In terms of pi, I had 83.8 square meters. I'm just thinking it's kind of icky. 32, let's see, that would be 16. 90 pi over 2, I think. Something gross, if anybody did it. 90 pi over 2 square meters. Anyway, let's just leave it in a decimal form since it said to do tenths. Okay. Okay. You can just take 8 squared divided by 2 times, what was the radian measure? I forgot. 5 pi over 6. 5 pi divided by 6. You're welcome. Okay. And the next one, I think we have to convert. What does that have? I don't know what that was. 285 times pi over 180 would be your first step. Yeah. Oh, and then multiply that by 13 squared. And something is strange here. I don't know if there's like something I'm not seeing that's there, and I don't know what's going on, but my cursor keeps disappearing in that section. Anyway, you can actually type this all at once. 285 times pi divided by 180 times 13 squared. And it's going to be 420.3 square centimeters. Make sure your units are square units and they are present on your answer. Questions? Did you not get it? Okay. Okay. Graph. All right. At least 5 ordered pairs. This would have an amplitude of 2. This is 1/3 theta. So the period would be 2 pi divided by 1/3. You change to 2 pi times 3, which would be a period of 6 pi. All right, this is already marked off in pi increments. The amplitude is 2. The center line would be 0. So we're going up to 2, down to -2, staying between those lines and doing it in this period. So halfway, bless you, would be 3 pi. Half of that would be 3 pi over 2. 3 pi over 2, 6 pi over 2, 9 pi over 2 would be halfway between 4 pi and 5. Okay, and then we can graph the function. It's a cosine, so it's going to start up high, then come to the center line, then go to the min, back to the center line, and then up to the max. Make it curvy. Oops. Label your 5 points, and you can just stop with that graph. 0, 2 is the first one. 3 pi over 2, 0 is the second one. 3 pi 0 is the third. And I would rather you did this than write them across the top or bottom of the page. And some people doing that. 5 pi over 2, 0. And the last one was 6 pi 2. Right. Number 14. And this one has a center line or a vertical change of up 2. So that means y equals 2 is your center line. What did I do? Did one of them? Oh, I was supposed to have a -2 right here. So sorry. Yes, ma'am. I wrote it. I saw that as a 5 pi over 2, so I made just 2 stupid boo-boos. You know what? I gotta be honest with you. My brain has been very flaky. I have been like, my mind is on something else. I have something else I'm thinking about, worried about. I have got to stop that. I gotta focus. Okay, this was not 5 pi over 2. It was 9 pi over 2. Thank you for saying something. Appreciate it. I will get focused now. I was thinking of what I wanted to do next. I honestly, sorry about that. Oh my goodness. I did this already once today, so I need to get fired up about it again. All right, now you got 2 my center line. Everybody happy with that at least? Let me do this one very carefully. I've got an amplitude of 4, which means I got to count from the center line up 1, 2, 3, 4. Okay, that will be where I max out. That's your max. Maybe I should label some of these things. Min would be down 1, 2, 3, 4. So this would be where your minimum is. Okay, amplitude determines how far you are above and below the center line, wherever that may be. Now, you've got a B value of 2, so the period would be 2 pi divided by 2, which is pi units. So we're going to complete one cycle in pi units. So that means I got to split this up properly. So I have already at pi over 2 marked. I need pi over 4. Then I need 1 pi over 4, 2 pi over 4, and I need 3 pi over 4. Okay, so then I'd say, okay, this is a sine graph, so it starts at the center line. It's not a reflected graph, so I start going up, back to the center line, down to the min, back to the center line. Okay, now the points are 0, 2. The second one is pi over 4. Is that 6? Yep. Pi over 4, 6. The third one is at pi over 2, 2. The fourth one is 3 pi over 4 negative 2. And the last one is at pi 2. Like that I lost the smoothness of my graph. Oh well. Then we have 2 where you have to write the equation. This worksheet 32, if you don't understand this or you really don't know what to do with these, you better start looking at that worksheet. State the amplitude, period, and any vertical shift. Write the equation of the graph shown. Okay, so what we have to do is we're putting them in the form k plus or minus the sine or the cosine times b times x minus, and I forgot one thing. What was it? A. Okay, that's the format. It's one of these. This one, you got to find the center line. How do you find the center line? Well, you go to the max, the high point, and the low point. You can take max plus the min, 6 plus negative 2, and divide by 2. That's going to be 4 divided by 2, which is 2. Center line should be at 2. Now, the amplitude, you can calculate it by subtracting the max and the min and dividing by 2. But why not just count from the center line? 1, 2, 3, 4. That's your amplitude. It's down 4 from the center line also this way. And so amplitude is always positive. It's 4. The vertical shift was up 2, which gives you a center line, y equals 2. Period. I have a look at this and I see a sine wave. And it stops, bang, right there at 6 pi. So if the period is 6 pi, we need to figure out the b value. B, I told you to find by taking the old period, 2 pi, dividing by the new period, 6 pi, and then reducing to 1/3. So b is 1/3. So now we're ready to write the equation. 2 plus amplitude, 4, times, this is a sine graph, sine of, the b value is 1/3. There's no phase shift, so it's just x or theta. I don't care if you use x or theta. Okay, the next one. Yes. Mm-hmm. Yes, you could. They got the K at the end? Yeah. If there's something, is it's the format just says, and it says D? I don't know why we put it.
A sine B and X plus B. And when I was going through like your videos and if you watch them, and that still kind of makes this like music. I feel like that. It was still the same.
I'm going to have a look at the reference sheet 1 second. So we just noticed that on our reference sheet, sometimes they have a value at the end, and that is just like K. It could be, it's just whatever's added either in the front or the back is the vertical shift. All right, so now let's take a look at 16. Not much of an amplitude on that thing. I see that it maxes out at 2.5, or actually negative 1.5, and minimum is at negative 2.5. So it's only got an amplitude of 0.5 or 1/2. No, don't really care that much. The period 1 cosine wave is happening in pi over 2 units. The vertical shift is down to negative 2. So this is your center line. You can kind of see it. Down 2. So your center line is at y equals negative 2. So that's maybe how you want to start or end the equation. I'll just start it with that. Okay, and then this looks to me like a cosine. And it's opening up, so it's not negative. So it's going to be plus. And then what's the amplitude? It was 0.5 or 1/2 cosine. And now I got to figure out the b value for the period. So 2 pi divided by pi over 2. So what is the b value? That's what how you get b. 2 pi times 2 over pi gives you 4. So it would be 4x or 4 theta. All right. That is the end of the quiz preview. I'll now take questions on anything else you'd like some help with. I think I'm not going to record that part, though, because it varies. Fast to do number 3 on 41A. I'm just going to write them up here instead of opening up all the smarts. Okay, so it says the football field is irrigated by a circular watering system with a radius of 130 feet. R equals 130 feet. Got one dimension already. The system will cover a 270-degree sweep with water in, and it happens in 2 minutes. So it does 270 degrees in 2 minutes. Find the area. Okay, area formula is 1/2 r squared theta, and you have to have theta in radians. So this isn't in radians. What's 270 in radians? We should already know that by heart. Yep, so theta would be 3 pi over 2. Okay, and now this was actually, sounded like an angular velocity, but I guess that was just my time. I'll just write down what time is. It was 2 minutes. I don't really need to write it as an angular velocity. We need to just find area, so we don't have to write this. It's just a time. Yeah, because you're just doing area. This actually could have been converted to an angular velocity. It would be 3 pi over 2 divided by 2, and I'd have to 3 pi over 4 radians a minute. But we aren't needing that because we're just trying to find the area. So all you need to do is plug in your radius of 130 feet and square it, and then multiply by 3 pi over 2. And if you left pi in the answer, it's 12,675 pi square feet, or in a decimal form, 339,819.7 square feet. Okay, we're going to look at worksheet 32 and been asked to do number 2. If my smart will open up, I need a picture so I can explain this. Okay, this is worksheet 32. I've been asked to look at number 2, and I finally got it open. All right, now, so if you were going to decide what this is, what do you really want to look at? Well, you want to look at where it intersects the y-axis. And then you're going to look at one cycle. You should know what one cycle is supposed to look like. Okay, this thing is not got a center line at 0. So I look at what the amplitude was. It goes from -5 down to, +5 down to -3. So that would be, a way to find the center line is to take 5 plus -3 and divide it by 2. So that's 2 divided by 2, which is 1. Okay, that's max plus min divided by 2 gives you the center line. So your center line or vertical shift is up 1. Right there. Okay, and then you can say the amplitude, just count it. 1, 2, 3, 4. It's 4. Positive 4, not negative. Amplitude's always positive. And then the period is 2 pi. So B will just be 1. Is this a sine or a cosine? Cosine, because it starts down low. Cosine. I don't know why I circled it. All right, so then I'm reflected. So it's reflected. So I'm going to start with my center line if you guys want to do the 1 first, or it could be at the end. Minus 4 times the cosine of theta, or x. That's it. I was asked to look at another one that's got a negative a reflected graph. Let's see, 7 would, because it goes down and then up. Now, this one, the center line is at 10. Vertical shift is up 10. It's reflected, so it's going to be minus whatever the amplitude is, which is down from 10, 10, 20, 30, 40 is your amplitude. So it's going to be minus 40. This would be a sine. The period is going from 0 to 8 pi. So B would be 2 pi divided by 8 pi. And that's 1/4. All right, so the equation is 10 minus 40 sine 1/4 x, or theta. You're welcome. Why don't you do number 8 and see if you get the right answer? Or number 9? Just do. No, you can do any one you want. I don't care. If I were you guys, I'd make sure I did these. I've been asked to do number 9 on book page 900. I'm just going to do it right here. It says the cotangent, well, I'm going to go ahead and, well, no. Cotangent theta times cotangent theta plus tangent theta equals cosecant squared theta. Okay, cotangent of theta is cosine theta over sine theta. Well, I think I wouldn't bother doing that. Did you think about doing distribution right away? Well, you could. Cotangent times cotangent would be cotangent squared theta. So did you do all the sines and cosines? I can do it that way too. Well, this is if I distribute it, right? Now, let's go ahead and change to cosines and sines. Okay, so this would be cosine squared theta over sine squared theta. This would be cosine theta over sine theta times sine theta over cosine theta. Okay, and then you could change, this would be, well, I could go back to, this is just 1, right? So I might as well go back to that's cotangent. No, I better not. Okay, next what I'm going to want to do is make this have the same denominator. So I'm going to add 1 by, I'm going to make it be sine squared over sine squared. Bye, guys. And now I can combine the numerators. Scott? Yeah. So if I combine these numerators, that's actually going to be all over the sine squared. And the cosine squared plus sine squared is 1. And now I can say 1 over sine squared equals cosecant squared. So the last step was to write cosecant squared theta equals cosecant squared theta. And that is how you have to do it. Do you want to check it?